Testing sound? Sound? Test, test. Oh, sound is clearly working. So, last time we were here, I was in the process of trying to test stuff. And having some difficulty. I did actually off stream, because I got kind of obsessed. Fixed one problem. But then I encountered another problem. And that problem turns out it's because I forgot something important in implementation time. And the important thing that I thought I forgot at implementation time made me realize that I did not have to actually put expression statement here. I can put instead statement if I would like. And that would still work. I don't have to have it be expression statement. And I think that I don't want I don't think that I want this to be restricted to expression statements here. This is great. One of the reasons why I want to do this is because of some anomalies involving semicolons, where if I don't do this, they won't. Things will work out strangely. The other thing that I forgot was this shouldn't go here. Oh, actually, I could still have it be expression statement and fix not have the weirdness involving semicolons. Do I want that? Partly the reason why I didn't want to do that is because this disallows assignment here. So I think I'm not going to do that. I think what I'm going to do is change my grammar around. Because this is the part of the grammar that I forgot to implement, is that part right there. And I'm going to have here this. And so then I can have another if statement in here, or I can have an assignment, or I can have an expression statement, any number of things. So I think that's what I'm going to do here. And this does mean that parsing a sequence, one, should be broken up. There should in fact be a parse statement as well as a parse sequence. So this is actually a pretty major change in order to fix tests, which I don't like. So what I'm going to do here is I'm going to take the failing tests and just disable them. That is what I'm going to do. So let's run this again. All I've done is change the comment around. I can actually do some special commit things to make that not work, be okay. So the ones that are all going to fail, this should work. This should work. This should work. This should fail. nested if statements. Given nested if statements. Yep, so this one fails. Let's ask So we'll ask Claude. We're basically using Claude as documentation here. So what does it say? Aha! So it says that I can do this. I can actually give it the disabled tag temporarily, because I know that this test will fail. It thinks this should work. Okay. I think that Claude might have been mistaken about exactly how this is supposed to work. let's ask let's try what happens if I do this. So test case aha. So actually, maybe I can just do let's see what happens if I do this. Hello there, Sky. Not see here. I'm trying to figure out how to make catch2 do something using the how to get catch2 to do something. Okay. I'm trying to do the BDD style for these tests. And it wants... Oh... So it seems to say that I can only give a second parameter to the then clause, or to the, yeah. Which is kind of annoying. Because I want to disable this test because it requires something that is currently not implemented. Um, so we have this here, required, da 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 da. Okay, how do I... Okay. So what I could just do instead is do this. Put this in here for the given, which is a little ugly, right? And then, oh, except I want to know what the, there. Like that. Give in nested if statements like this. And then, comma, like that. Let's see what happens if I do that. Oh, and then here, we just remove this part right there. All right. That looks like it ran. Let's see what happens when we run it now. Okay. If statement with assignment in branches. It correctly discerned that, so one, we're going to do this because I'm going to fix it so that we don't have to do this. I'm going to fix the grammar. But also, we're going to do the scenario thing again. and then disabled. And again, it should be like that. And it isn't supposed to be scenario, it's supposed to be section. Okay. And yes, that close is supposed to be there. All right. More stuff not working this time. If statement with assignment in branches, which yes. When the tokens are parsed. But this dot disabled should disable it, right? Just to copy this here, just to stop that. Yeah, that was, it should be disabled. What is wrong? Why is it not disabling? So let's make this bigger so we can see it. So I can add tilde dot disabled to the command line. How's this? Edit. No. So that's how you put a filter on the command line. And that's the dot disabled tag. That's how that should work. This filter, command line, filter, tilde, some tag. A test case is hidden if it has the benchmark tag or any tag with a dot at the start. So I should already be disabling it because the tag has a dot at the start. And so I shouldn't have had to have done this. Shouldn't have had to edit the configuration to change how it's run. So let's go into the CMake build debug. And then let's say set the velocity to high, and let's see what happens. Catch 2. Okay, so sections you can't have Okay, so tags can only apply to they can't apply to scenarios. So, or they can't apply to sections. So I'm just going to have to go back to what I had here before and dike it out differently. And lest anybody think that that comment was referring to something that I wasn't referring to, it's a standard terminology used in electrical engineering to refer to in electronics and hacker slang. Dyke it out means to remove or disable a portion of a system, such as a wire from a computer or a subroutine from a program, often using diagonal cutters, which are commonly referred to as dikes. This term originates from the literal use of diagonal cutters to snip wires and is metaphorically extended to information systems with the slogan, "When in doubt, dyke it out." So that is what dyke it out refers to. And in this particular case, we're going to remove some test cases that aren't working. So here's how we're going to do it. We're going to do it this way. Like that. And here, so I'm going to search for the disabled tag. There we go. And then here, now the second parameter shouldn't be here. And now we're just going to if zero it out. This should be fine. So all these other test cases should be great. It's just those two that are a problem. And we have some failures, but they're not those kinds of failures. And I'm willing to live with these failures for now. We will go back and fix these failures later. I need to look over exactly how the printing out code works. And I'm going to commit the way it exists right now. And is slightly wrong. So putting the -I before M is basically interactive, which kind of allows me to sort of piecemeal go through and add in changes. I think what I would like to do, quit recording no changes. So let's make sure that this is 68 characters or less. Nope, 74. That shortens it a bit. Let's see if I can. One more, still test. Let's see, I want 4 more characters in here. There, that's a good way to do it. No, no, no. This, and then we'll get this, and we'll go back up here, get this back, that, delete all that. There, better. Okay. Now, yes, that is a fix for a test failure. That is also a fix for a test failure. That is also a fix for a test failure. That is also a fix for a test failure. Also a fix for a test failure. Yes, we want to look at this. No, we won't record this change. No, we won't record this change. Yes, we'll look at this. Yes, we'll add all of these tests, although there's a bunch of lines with blank lines at the end of them. So what I want to do here is find all the ones where the oh, here we go. Here's one. There we go. So let's look for some more of these. Boing. Yep, right here. Okay. That should work. Slash. Maybe that works. Aha. Okay. I'm learning more about VI than I made some guesses about how VI was supposed to work, and I was right. And now I'm using VI to do my editing, even though I don't like VI very much. I should fix this so that it doesn't use VI to do the editing. Basically what I'm doing is I'm finding all the lines that have blank lines at the end and getting rid of them. And that's what I successfully did. Okay. So now that I've done this, I'm just going to revert parser test.cpp because all of these editing changes are ones I want to keep. I don't want the spaces to be added at the end. Oh, come on. There we go. All right. So, there. And now, there. Update the grammar so that statement, basically a statement gets to change so that one of the things that can be a statement is a sequence. Which a statement sequence is a statement. This is going to be weirdly recursive, but of course this doesn't say just plain old sequence here. So statement could be a sequence, but statement actually has to be an open brace sequence, closed brace. And so, yes, this doesn't result in ambiguities or weirdnesses. It just looks weird because of the odd mutual recursion. Then I changed this to be a statement instead of expression statement. So now statement, it allows brace sequences as being in there as well as assignment statements, which it didn't before. Now what we are going to do here inside the parser is going to add a new function here. And it is going to be called parse statement. Just like this. And actually, it can probably be done like this. Except that, what column is that? That is column 101. Nope, can't be done that way. Has to be done. Oh. If I do this, stop that. If I do this, now that's column 86, still too much. So I still have to do this, 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 there. All right. we will have parse statement here. And parse statement is basically just going to copy part of parse sequence. Yep. And then, so basically, if we're at the end, we stop. Otherwise, we say statement is this. And then we try out all of our possibilities here. But one of the things we have to put here is if tokens brace curly bracket Okay, how do we handle this holds alternative thing than other places? We have a new method for doing this that we started using. Holds alternative, we're looking for keyword, so actually what we want except we don't want tokens parent. And we don't want equals equals, we want equals. Yes. Like this. No. Like this. Yes. And then like that. Like this. You stupid piece of garbage thing. What are you doing? No, I want to close there. You dumb thing. Okay. Now we start forward. We say statement remainder equals parse sequence, blah, blah, blah. If statement, no. Oh, this is ugly. This is ugly. I just realized. But no, if we get a curly brace, if we start with a curly brace when we're parsing a statement, okay, we're going to special case this. Here we know that if we didn't in fact get the thing we're looking for, that this in fact is a parse error. And then we don't have an else here. So, no, this is if not statement. And then we check. Like this. We check to find out if otherwise we say then we say and we do return like that. And then this is not an else anymore. So then start equals the next token, we eat the brace. And then in here we do return we just say statement equals move statement after equals start. There. And then here we can do else. All right. And then here we can just do return. There we go. And this should be one block over, like that. And so should this. All right. That looks correct. Now we should say and this, if we fail, this is another case where if we fail, it's not actually the end of the world. Start equals remainder. There. Actually, what we'll do here, if not statement, no, actually here we don't return an error. And otherwise we do this. You know something. What we actually return here, oddly enough, is Yeah. And so that just means basically if we do that, we should break. If not, statement break. All right. Now let's see if our tests work any better, or if any of our tests fail. That weren't failing before. No, those tests were exactly the tests that were failing before. Okay, well that's good. So we didn't break our parser doing this. That's always a helpful thing. All right then, let's go back to our parser test, and let's undike out the things we diked out. We'll take this one out first, and we'll put this one in first. That didn't work out very well at all. So this should have worked, but it did not. So let's see what happens when we actually run this and see what happens when we actually try to parse it. Okay. Where was I in this? Parse sequence. Okay. So we're here at invoke, but I can't tell what test is being run at the time. Like, what test is this? Oh, this is annoying. Let's see if there's any terminal output. No, that's not what I wanted. Debug, and I wanted that's not helpful. Okay. That's not helpful either. Okay. Oh. Maybe I need to put the breakpoint here. That's really annoying. Okay. Okay, so we're here. Now let's see here. Let's go look back in catch main in parser. I like the odd smileys. Let's go here in parser. Now let's actually put a breakpoint in parse sequence. There's probably a way to have a conditional breakpoint that only runs if another breakpoint has been. I don't need this, don't need that, don't need this, don't need that, don't need this, do need this. Parse sequence. Okay. Now let's do continue. As I said, I wonder if there's not a way to set some kind of debugger variable when one breakpoint is hit and then have the other one conditional so that one breakpoint only fires if the first breakpoint is also fired. Anyway, so we have our tokens here. And we have if. And also we were in parse test here when tokens are parsed. So the first one should be if. Yep. Okay. So yes, we're going to do this. Yes, we're going to do that. This gets the statement list part out, and it's been optimized away, which we'd kind of expect. Now, let's step into this. Step over, parsers. Nope, it is not that. So then we go to this part here, else if. Then we do this. Step into. Step over. So we see an if. hey, this should have been a tokens base value tokens keyword. This should have been a token keyword. What? Oh, this is the failure case. This is a success case. So yes, we are looking at an if. Okay. Silly me. Step over. So start is now equal to the one after that. It is not. Let me check. Okay. So it was an open parent. And so then we do this again. So we in fact do get an expression here, which that's what I would expect. Binary operation, which given where we are in parser CPP or the test, parser test, oh, it should be numeric literal is what we should be getting as our top level thing here. And we are not. Oh, no. Oh, it is a numeric literal. It's a 1. Okay. The contained value is the numeric. Okay, we're good. I was worried for a minute. I was wondering, what the heck happened here? So, yep. So start doesn't equal to finish. And we step in. This should be a parent, close parent. And indeed, it is a closed parent. Because otherwise we wouldn't have gotten here. Oh. Now we check. Oh. Silly me. I didn't fix this part. Now, what we should do is we should dike this test back out again. Then try to run all the tests that were supposed to work and see if only the ones that fail, only the ones that are supposed to fail. Okay. We only get 2 failures, and they're the ones that are supposed to fail. So that's good. Now back to seeing if this works. Again, we wanted to make sure that we didn't break our parser with the changes we were making, and I was seriously worried that the parser had gotten broken. That changing expression statement to statement would cause the parser to break. This is still failing, and I am starting to get really tired. I think that I'm going to leave debugging the rest of this to the next stream. Only the Sky has shown up so far. Thank you very much, Sky, for joining me on this stream. And I'll be talking to you in person on Wednesday. Until then, I hope that you have a marvelous week.